hospital.
Yes.
Okay, where? Yeah.
It's usually for
In
brain,
case
like spinal cord and vertebra. Vertebral cord.
Mammography, CT,
CT or computer tomography. Okay, with the abbreviation of CT. Another one,
angiography,
angiography. Okay. Your course title is medical physics. Okay. Mainly describing different modalities in medicine, including radiology, mammography, radiography, SPECT, PET, CT, and MRI. I want to teach you about MRI and optics imaging. First, I have to check your attendance. I have to. Speaking about magnetic resonance imaging. Primarily, the magnetic resonance imaging was called nuclear magnetic resonance with the abbreviation of NMR. Have you heard anything about NMR?
Yes.
Yes? What is NMR? Nuclear magnetic
Medical
resonance. NMR. Chemists often use this modality, okay? Because NMR generally is used in laboratory
Understood.
when we are characterizing a material, a chemical compound, okay? But in this process, a variety of names and abbreviations have been applied to this process. What process?
Ma'am,
What process we are
can you
speaking
speak
about?
loudly? Can you speak loudly? We can't hear.
Loudly?
Yes.
I can't hear you. A variety of names and abbreviations have been applied to this process. What process I mean? The process of acquiring signal from magnetic resonance imaging. To have an image, to have an MRI image, we have to acquire signal from magnetic resonance imaging. But in this case, we have different names and abbreviations. For example, we have MR, we have MRI, we have NMR, and in some cases, we use these terms interchangeably. Here we want to understand what is the basic processes of these terms. I mean MR, MRI, NMR, if there is differences between them or not. Or maybe they are synonyms, okay? Or not. We are going to understand about these concepts in this course. In 1940, this phenomenon was called nuclear induction. The first name used for this phenomenon was nuclear induction. In the early 1950s, it was called nuclear for magnetic resonance. You are hearing different terms for just one phenomenon during the time. The first name was nuclear induction. Then another name was nuclear for 1950, the term nuclear magnetic resonance and MR has been preferred name for this phenomenon. Nuclear magnetic resonance since the late 1950. But then imaging methods using the NMR signal were first developed.
Can you change the slide? Or is the same slide?
Oh, okay. I can see the next slide on my PC. So I thought
No,
I
it's okay.
changed it. Excuse me.
So,
Then imaging methods using the NMR signal were first developed. The term NMR imaging was applied to them. NMR imaging was applied to them. But some patients concerned over the dangers of nuclear energy, nuclear materials, nuclear radioactivity. So the word nuclear had been largely dropped when referring to this phenomenon, when referring to these imaging methods. And magnetic resonance imaging was simple like MRI became the preferred designation for this new modality. Okay? Magnetic resonance imaging or MRI. Currently, this term is common. Okay? In medicine, it's very common these days, and we are using this term these days. Okay? MRI. But lexicon has even further expanded now to include such terms as magnetic resonance angiography, magnetic resonance spectroscopy, functional magnetic resonance imaging with the abbreviation of FMR. Then we are speaking about the conventional MRI. We say just MRI. We are using, for example, we would say we are using the MRI scanner. We are looking at the MRI image. When we are speaking about the conventional MRI, okay? But when we are speaking about advanced MRI, we have further terms including functional MRI, diffusion tensor imaging, diffusion weighted imaging, magnetic resonance spectroscopy, and such terms we can use when we are speaking about the advanced MRI. Advanced MRI. So we have conventional MRI, we have advanced MRI. MRI is very advanced. We have lots of advanced techniques in MRI, like functional magnetic resonance imaging, diffusion weighted imaging. Have you heard anything about these terms? Have you heard? No? At all? These are very advanced and important methods in MRI. Diffusion weighted imaging, diffusion tensor imaging, DWI, functional magnetic resonance imaging, magnetic resonance spectroscopy. These are very critical for you to know about these advanced modalities, advanced techniques in MRI. For the future, when you start your practice, you have to prescribe these advanced modalities to diagnosis, for diagnosis. Okay? For diagnosis of different lesions, different diseases, and I will teach you about these advanced techniques.
자,
So, using the term of NMR is preferable when we are describing this phenomenon in the laboratory. Okay, when we are characterizing a chemical compound, when we are understanding the underlying chemical properties of the material, okay? When we call it NMR. But when we are acquiring, capturing an image of a body, a patient, we call it
MR.
okay. That's very good. What is it? MRI machine. This is the table. This is gantry. There are many instrumental compartments of MRI. What?
pointer.
Two items very inactive. We call it gantry. This is a table of MRI machine. And these are different buttons to move the table up, down, right, left, to set up the patient into the isocenter of the gantry. Gantry, this is gantry. 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 This board is called bore magnet. Patient lies on this part of the machine. Okay. We have constant externally applied magnetic field within this board. The pen is inactive. Otherwise, I draw it on the screen, but the pen item is inactive. We have constant V0 or externally applied magnetic field within this ball. Parallel to the body of the patient, we have constant externally applied magnetic field. Or when a patient lies on the scanner, in fact, he is placed within an externally applied magnetic field. Okay. In the MRI, we have magnetic field interaction. There is an interaction between our body and externally applied magnetic field. Using this process, we can have an image in MRI.
I have a doubt. Why is the machine so loud?
What's the machine?
So loud. When we're in the machine, it's very loud. Why?
Okay, because this existing different instrumental compartments of the machine in the gantry cause this noise with so loud voice we can hear. Okay? there are different tools and compartments in the gantry, okay, can cause noise. Do you know anything about noise? Sometimes we are saying the street is very noisy. Okay. Some instrumental compartment of the gantry cause this noise. Okay. This is ball magnet. This is a cross sectional of these ball magnet. If we have a cross sectional,
We cannot see them.
Pointer is not
Can you use the
visible.
pointer, please?
I forgot. In this plane, you can think of having a cross sectional of the
Machine.
machine, the ball magnet, this
Okay.
ball magnet. This is a cross sectional plane of this ball magnet. Okay? These are very important. We are not going to seek very underlying mechanism of the MRI because it's very complicated. Definitely you cannot understand during this short time to but I try to explain a little bit about the MRI until you can understand something about MRI and what is happening in MRI. So, in some cases, I will not be able to explain more about the some mechanism occurring in MRI. Okay? I'm going to speak about some definitions in MRI. You know anything about nuclei? About protons or spins?
Yeah.
What is nucleus?
This is the
Center of
center of the nucleus.
The center of
neutron and
atom. We have a nucleus at the center of each atom.
We have particles in there.
Okay.
Proton,
neutron. Proton and neutron resides in nucleus.
positrons.
Nucleus consists of proton,
And neutron.
a number of proton and neutrons.
Hmm.
Hydrogen consists of just
One
One
electron.
proton.
one proton. Also, we have electron circulating around the nucleus.
Nucleus.
Electrons circulating around the around the nucleus.
Nucleus.
So, atom consists of nucleus and electrons. Okay. I want to tell you a fact in MRI. The acquire or capture signal in MRI from the electron or nucleus.
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 Proton. Proton.
Not proton. The entire nucleus.
Hmm.
The capture signal in MRI from the entire nucleus, not proton. But since in the clinic, in the typical clinical experiments, the capture signal from the hydrogen nucleus, and hydrogen nucleus consists of just one proton. The entire nucleus consists of just one proton. So, we use the term nucleus and proton as synonyms. But these terms have different connotations, different concepts. We know proton and nucleus are identical, but for the reasons I told you, we use these terms interchangeably. Okay? So we can use nuclei and protons interchangeably. There is no problem. In the case of MR. In the case of typical clinical experiments, where we capture signal from the hydrogen nucleus. What can make image in clinical MRI is
Nucleus.
Hydrogen nucleus.
Hydrogen nucleus. Just hydrogen nucleus. We can acquire signal from the other nucleus, but not in the clinical experiments. I have a question. What kind of nucleus can involve in MR? Do you think? I told you we can capture signal from the hydrogen nucleus. What?
Carbon. Isotopes, I think.
No.
Can you repeat your question?
Which types of nucleus can involve in MR? Can undergo MR?
Hydrogen.
Hydrogen.
What?
Hydrogen.
Hydrogen nucleus. This type of
Radioactive.
isotope.
Nucleus of group 1.
This concept is not relevant to isotope or radioactive atoms at all.
Which are
In the case of SPEC, in the case of PET, we are speaking about the radioactive atoms. But in the case of MRI, we are not speaking about the isotope or radioactive at all.
those
Because MRI is completely safe
those
and non-invasive. Okay? MRI is a non-invasive method. In the case of PET and SPEC, we are speaking about a kind of invasive methodology.
those atoms are elements which are abundantly found in our tissues, right? Hydrogen, carbon, nitrogen. These type of nucleus.
Okay.
Monovalent nucleus. Those atoms which have one valency, one proton and neutron.
I will answer one question. Each nucleus within our body, okay, have an interesting property which is called a spin can involve in each nucleus has an intrinsic property which is called a spin or
Spin.
a spin angular momentum can undergo MRI or MRI. A spin angular momentum is an intrinsic property that each nucleus has this property can involve in MRI, can give us signal.
Then, what is this spin angular momentum?
What is? A spin angular momentum is describing a property property of each nucleus that whether they can interact with externally applied magnetic magnetic field or not, or is defining the magnetic property of each particle.
Actually, the vibrating frequency of the both the rays match, then it's spin, right?
No.
Resonance means doesn't mean that-
Resonance
Yeah.
frequency? No. Let me.
I think a term which has less number of shells, orbits, have spin angular momentum.
Okay. Do you understand? Do you understand? Okay. Everything is okay. Can you understand what I'm saying? What is a angular momentum?
Ma'am,
Spin angular, as I told you, spin angular momentum is an intrinsic property. It can't say nothing about it. It's just an intrinsic property that defines the magnetic property of a particle. This property is describing the magnetic property of a particle. If particle if an atom has a spin angular momentum, it has a magnetic field around itself. Otherwise, you can't see the magnetic field around the particle. Okay?
ma'am,
For example,
Resonance function.
ma'am.
in this picture, we have a tiny bar magnet here. Okay. Tiny bar magnet with north and south poles. We have magnetic field around this particle. Okay. In this case, we have a tiny bar magnet here. An atom has spin or angular momentum. We can replace it with that spin. That spin can behave like this tiny bar magnet. It means this spin can have the magnetic field around itself. For example, hydrogen nucleus has magnetic field around itself. Okay?
Always. I mean, without external applied magnetic field, it always has the
without
spin.
applying external magnetic field. Hydrogen nucleus has magnetic field around itself because it has a spin. It has a spin angular momentum.
Then every atom has a magnetic field around it because magnetic field is produced when a charge moves. Electron is in every atom and it moves. So like magnetic field is around every atom. I think.
Okay. I can't understand your pronunciation.
Then
Pakistan.
yes.
Can you understand my pronunciation? But you can't understand your pronunciation.
He's saying electrons are present in every atom, and the magnetic field is produced by the movement of electrons. So
No.
every atom should have magnetic field around it.
magnetic field of electrons is not important at all. Just magnetic field around the nucleus. For MRI, the magnetic field around the electrons. We all know electron has magnetic field around itself, but it is not at all important here. Just magnetic field around the nucleus. Just magnetic field.
So this
So he's saying
Exists magnetic field. Exists in the case of space with in the case of nucleus with space. Nucleus having space.
then
Be quiet. I'm hearing some noise. Okay.
so this spin angular momentum is due to the spin of proton.
Spin angular momentum is due
Electron,
to
that's it.
okay
Due to proton, I think it is due.
due to
Proton,
proton.
yes,
In the case of hydrogen,
yes,
it's okay.
proton.
Sorry.
So proton is also present in every atom.
Okay.
So why there is no any magnetic field around? So why there is no any magnetic field around other atoms?
Every atoms.
Because they don't have a spin. They don't have a spin.
which type of atom
If
is
you want
magnetic?
to imagine a spin, the easiest way
Revolution.
is
Revolve.
okay. What is the meaning of a spin?
A
What is
rotation.
the meaning of a spin?
No, spin and rotation.
Charqedan.
Okay, okay, that's right. Charqedan.
Hello. Yes, sir. The electrical does electrical field have a role here? Because electrical and magnetic field are all always parallel according to the laws of physics. Does the electrical field have a role here? Because the electrical and the magnetic field are always perpendicular to each other according to the laws of physics. We have studied in
Yes.
previous classes.
Is all proportional.
Yeah, but here it doesn't have any role in the MRI.
No.
Why?
The magnetic field of electron at all affects on MRI. We are not capturing the signal from the magnetic field of electron because we can set our acquisition so that we capture a signal just from the field. These are very complicated phenomena. We are lots of statistical formula and complicated processes within these phenomena.
The externally applied magnetic field are parallel to our body or perpendicular to our body.
Okay.
My question is this. Manzura Meena.
Yes.
We are apply the external field. These passes parallel to our body or perpendicular to our body.
Perpendicular to the B0.
Perpendicular.
Yes.
It is, yeah.
But we are not speaking about the external magnetic field. Okay? We are speaking about the natural magnetic flow nucleus.
And
We haven't applied magnetic field yet. Okay? We are speaking about a natural property. We haven't yet applied magnetic field. We are speaking about the magnetic property of the hydrogen nucleus. Hydrogen nucleus has a magnetic property around itself. Okay? Did you understand?
Yeah.
Which type of atom has this magnetic spin magnetic momentum except hydrogen? Other atom also have this magnetic spin.
No. I
Only-
told you some of nucleus having spins show magnetic field around itself.
Can you do some
And
example?
otherwise, we don't have any magnetic field around the nucleus. That's enough. Hydrogen shows magnetic field. Hydrogen nucleus shows magnetic field around itself. Carbon shows magnetic field around itself. Fluorine shows magnetic field around itself.
Nitrogen.
But we might have a question. How can we predict the spin of a nucleus? How can we predict?
Compass.
Spin of nucleus.
A spin of nucleus.
Nucleus was
How
spin.
can I
Here is
predict
an spin.
a special nucleus has the spin value of a nucleus has zero value or non-zero value
Using vector.
using
Direction of the spin.
okay, but the value of a spin varies between 0 to 8. If the value of a spin is non-zero, we can capture signal from that nucleus. Otherwise, but we don't have a special formula to predict this value. There are some general rules to predict the value of a spin. We can't say what happened? What happened? What are you saying together? About okay. I have a lot of content to teach you, and we have a short time. But I try to manage my content. There are some general rules to predict the value of the spin. If we have a zero spin, we can't capture signal from that nucleus. Otherwise, we can acquire signal from that nucleus. For example, if we have even number for both proton and neutrons, we can't have any signal from that nucleus. But, or another case, if we have odd number for both proton and neutron, we can capture signal from that nucleus. Guys, just nucleus, not electron. Okay? So, some nucleus within our body have an intrinsic property called spin. A spin is describing the rotational behavior of nucleus around itself. Some nucleus have this property.
Rotates on its axis.
Okay, but some nucleus can't behave like this. Okay, if a special nucleus can have this rotational behavior, has a spin, and can undergo MRI. Okay? What happened? You're laughing. Did you understand? Okay. All of you. There are more complicated concepts behind these concepts. I can't tell you because they are really complicated. You can't understand. Okay? They used to teach MRI in 4 semester students who have specialties in all. So MRI is very, very complicated. You can't compare the MRI from the other modality. Other modality which are based on X-ray is pretty simple than MRI is very complicated concept, full of formula and statistics and such concept which is complicated. So you know about nucleus, you know about spin. Now we are going to speak about the other property, other interesting property which is called magnetic dipole moment. Have you heard anything about this parameter, magnetic dipole moment? Each nucleus has magnetic property around itself. It have magnetic dipole moment, electron quantity. For example, in the case of tiny bar magnet, we have magnetic momentum. We studied in the high school, I don't know,
Actually,
magnetic momentum. Each material has magnetic property around itself, has magnetic momentum. A vector quantity to measure whether this particle can interact with the external magnetic field. Okay? Magnetic momentum defines the interaction of a particle with the external magnetic. If a particle has magnetic momentum, it means it can interact with the external magnetic. Okay? Each particle, each nucleus has a spin, has magnetic moment, which is which is a vector quantity. What is a vector quantity?
which have direction and magnitude.
Magnitude.
Both direction and
It has magnitude and direction. Two important elements: magnitude, and direction. Two factors are important for the
vector quantities.
So, if I'm sitting here, I have lots of hydrogen nucleus within my body. Hydrogen has a spin, hydrogen has a magnetic momentum, hydrogen has part of my bar magnet here. I must absorb it, but what happens?
Direction is
Do I have magnetic property? Oh,
Because
Actually,
hydrogen.
my body is full of
hydrogen.
Hydrogen.
what?
Hydrogen.
Hydrogen.
Hydrogen, okay. But why? Don't magnetic property.
Because it's spin of protons.
These are perpendicular or parallel to the direction is opposite.
Interact them.
0 will be multiplied by sin 0.
Parallel
Sin
में
90
zero
will
है.
be
Imagine,
sin 0 0.
Parallel 0
look
है.
at that picture. Imagine this is a portion of our my body. Portion of my body. Okay. What is this vector?
Hydrogen.
This vector. These are hydrogen
Hydrogen.
nucleus.
Yes.
You know, we have lots of hydrogen within our body. Okay. 58% of our body consists of
Water.
composed of hydrogen. Okay.
5 to
58 or
16.
87.
85 for brain.
Okay. I don't know the exact value of this part. Look at this picture. These are hydrogen nucleus. This hydrogen nucleus have a spin, have magnetic moment. What is this vector? What is this vector?
Magnetic field.
Magnetic? No.
Magnitude and direction.
Magnetic
Momentum.
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 I'll explain it. I told you magnetic moment is a metric quantity to measure the
Spin.
tendency of an object to interact with the external moment. Okay? But as I told you, magnetic momentum is a vector quantity having magnitude and direction. If these vectors for individual space orients randomly within one body, the sum of these vectors is
Zero.
Zero.
So I don't have any magnetic property. When we are standing out of the MRI room, standing out of the MRI room, we don't have any magnetic property. We are full of hydrogen nucleus. My hydrogen nucleus has a spin, has magnetic momentum, has magnetic property around itself. But due to randomly distribution of these vectors, we don't have any magnetic property.
Can
The
see
bulk
that.
magnetic property of my body is 0. My hydrogen nucleus has magnetic property around itself, but the bulk and the sum of these vectors is 0.
Zero.
I don't have a magnetic property. What should we do here? In this point, what should we do?
You should apply external
That's fine.
to destroy them.
Then we rely on the Bohr magnet. Bohr magnet. Gravitational lie on Bohr magnets. First, we are standing out the at the next step, we are asked to lie on the Bohr magnets. In this point, we are placing within the external magnetism. In this situation, my body are composed of lots of hydrogen nucleus. Each individual hydrogen nucleus has a magnetic property, has a spin, as I told you, has magnetic moment. But in this situation, all of these spins are placing within an externally applied magnetism. Then we are lying under a spin, under Bohr magnets. The direction of V0 align the direction of Hessian line and the scanner is designated as Z direction. Got it. Is designated as a Z direction. We have Z direction, we have X direction, we have Y direction. This direction, the direction of V0 is designated as Z direction. It's very important. The constant magnetic field, as I told you, is aligned to the Z direction. In typical clinical MR machine. The direction of V0 is designated as the Z direction. So, in the Z direction, we have constant magnetic field. For example, we say,
Can you explain that again?
explain more
Isn't it?
again.
Where
ये बस समझ आया अब पिता मत यार
This is Bohr magnet, okay? This is Bohr magnet. You know what is it? You know what is the Bohr magnet, okay? Station. Lies on the Bohr. The externally applied magnetism field is applied in the Z direction. This direction is designated for the Z direction. If you have a cross-sectional plane, this plane is called XY plane. Okay, XY plane. This direction is Z, And we have a cross-sectional plane.
X.
Cross-sectional plane is called
XY.
xy plane.
XY.
These are very important points. You can see this picture. This plane is xy. Did you understand? In the case of applying external magnetic field, magnetic moment mu, its symbol is mu. Okay, will stick to a line with an external magnetic field. The magnetic momentum aligned with the magnetic field or opposed to the magnetic field. You can see this picture. In this situation, we apply magnetic, external magnet, which is constant in the machine. We can't turn on or turn off it. Nucleus or moon in this case aligned with the external magnetic field. Imagine external magnetic field is applied in this direction from this point to this point. Is zero. Okay? Okay, excuse me. In this picture, you can see the different alignment of moon, then helix within an external magnet. Imagine we have this zero here. For this nucleus, is this nucleus aligned with the external magnetic field? This nucleus opposed to the external magnetic field.
Cancel.
Two spin states up. Then the moon is placed within externally applied magnetic field. What we have in the ball magnets, spin aligned with the external magnetic or opposed to the external magnetic. You can see this picture. Two spin states occur. In this case, then we don't have any external magnetic field. The orientation of
Random.
moon is completely random. I don't have any magnetic property, body magnetic property, or some of the moon is zero. But after applying externally magnetic field, we have two spin states. We call it spin up. We call them spin up or spin down. Spin up, spin down. In this case, we call it spin up, aligned with the external magnetic field. In this case, we call it spin down, opposed to the zero or this externally applied magnetic field. What time is it? Are you clear?